Mark van der Heij, Joseph Akaba, Alexander Masurkin, Scott Tingle, Norishiki Kanai and Anton Skaflerov. These are the 6 that form the answer on the question, how many people are in space right now? .com. These 6 astronauts use about 840 grams of oxygen per person per day. In total, that's about 5 kilograms a day. How does the ISS get this oxygen? Sending containers with compressed air into the sky is one solution, but a very expensive one. Launching costs tend to be in the order of $95,000 per kilogram of supply. That would result in costs of almost $500,000 for sending pure oxygen. Sending compressed air, which only contains 23% oxygen by mass, would result in costs of more than $2 million per day. Even the cheap SpaceX rockets will result in skyrocketing costs, so it should be obvious that a cheaper system is desirable. So in July 2006, the OGS, which stands for Oxygen Generation System, was launched into orbit. By using a chemical process called electrolysis, water can be transformed into oxygen. It works as following. As you may know, a water molecule is a combination of 2 hydrogen atoms and 1 oxygen atom, H2O. By adding 1.23 volts of electricity, water molecules will get split and form hydrogen and oxygen molecules. Completing this chemical equation shows that 2 of these water molecules will result in 2 hydrogen and 1 oxygen molecule. And since the weight of each molecule is known, we see that 5.7 kilograms of water is needed to provide for the 5 kilograms of oxygen. This water is obtained by recycling wastewater and urine. As a side effect, 700 grams of hydrogen gas will also be formed with this chemical reaction. This gas is highly flammable and also explosive, so that should be taken care of. In an ideal situation, plants and other flora would be used to generate oxygen out of CO2. This would be called a bioregenerative life support system. Although several dozens of square meters of plants for every crew member is needed, this would be a very sustainable way of generating oxygen. Experiments on this matter have already been performed, but had severe problems with the rate of growth under microgravity. So for now, we are stuck with the OGS, but that could change in the upcoming years.